Hi, in this video we will be looking at section 3.7 in the 2024 IGCSE syllabus of marine science, and that has to do with migration. And we'll look at migration in different animals. The case studies we'll be looking at are turtle, humpback whales, and last but not least tuna. We'll also look at the difference between horizontal and vertical migration, and we will look at different ways of animals to do navigation. This is a quite huge part of the syllabus, and it's a new thing, so I think it would be a wise thing to pay attention to it. Very often when we talk about migration in biology, people often think about the long journeys of the wildebeest or migratory birds, like animals moving over quite a long distance. And in marine science, we will be looking at that as well. Animals like humpback whales who are moving a long way from where they are in summer to where they are in winter. But migration can also be a much shorter range and over a much shorter time scale. As we will discuss later, it can be as much as a daily one where during night you swim up and you feed, and during day you go down in the deep again to avoid predation. So generally in biology, animals move for a reason. Of course, we all seen the clips of dolphins jumping for fun, but most animals do so for a reason. And the overriding reasons here are food. Food supply is, of course, highly important, and for some animals, that food supply can be seasonal, or it can vary over the day. So for that reason, moving to different feeding grounds is a huge thing. Finding mates is also important. If you're a solitary animal, it can be quite hard to find a mate. But if all the other number of the species go to the same place for mating season, it makes your chance of reproductive success that higher. Spawning is another thing, and I think we all seen the videos of the salmon returning back to the river where they came from, or the leatherback turtles going back and laying eggs on the beach they came from. That also requires migration. And then there's avoiding predation. You want to go somewhere where you don't get eaten. All of these are very valid reasons for moving, and as we'll look into the different species later in the chapter, we'll look at why they do it. Now, during World War II, which wasn't good for many things, but from a marine science point of view, it gave us a lot of discoveries of the seabed and extended use of sonar. Allied ships saw a lot of movement in the water of biomass going up and down, and didn't really know what it was. It was, in fact, the large number of organisms that do the biggest migration every day. You have a lot of species who live down in the twilight zone during day, and then during night they move up in the water column. During night there's darker, so there's less chance for predation. Many predators in the top of the water, they use light to identify their prey. And there's a lot of algae and plankton floating around, so there's a lot of food. So you have organisms who go up there during night and then down during day, and you get this big elevator going up and down every 24 hours. This vertical migration is also important for recycling energy, because as the animals go down on the pressure here, whatever feces they get rid of rains down then as marine snow, and then descend to the bottom of the ocean and powers the food chains there. So here we see a graphic representation of vertical migration, where we have a lot of the active predators up in the top during the day, and then during night we have a lot of species moving up during the cover of darkness to do their feeding, and then when the light comes back they move down again into the relative safety of the twilight zone. To talk about horizontal migration, we are going to look at three different species: tuna, loggerhead turtle, and whales, and in the whales we especially be looking at the humpback whales. The loggerhead turtle, like many other turtles, the female go back to the beach where she was hatched herself, and then she lays her egg in the sand. When then those eggs hatch, then the small turtles then have to crawl back out into the ocean, and then they have the quite hard job of them themselves growing up to become adult turtles. So once the small hatched loggerhead turtles are out in the water, they still have a rough job of going up, and because of that, they do migration. The turtles are moved by the current system in the North Atlantic Ocean that circles around the Zaragoza Sea. And eventually, they will complete the circuit of the North Atlantic and that will turn into Florida, where they breed. An advantage for them is that the small turtles go out into the open ocean where there's less predation. The small turtle is less protected and is an easier victim for predation. So it's smart for them to be out in the open ocean. So while there's less food, there's also less chance of predating. And then when they have to breed and hatch, they go back to where they came from. So this figure shows migration patterns of the Pacific tunas, the bluefin tuna in this case here. The bluefin tuna spawns in specific areas in the Western Pacific near to Japan and China. And after living about a year and feeding in those areas, most of the tuna, they migrate across the entire Pacific Ocean where they swim and they grow large in these waters for another 2 years before they then return to the spawning ground. And while swimming back to the spawning grounds, the tuna becomes sexually mature and then ready to spawn. And after spawning, some of them return back to the Eastern Pacific. And the bluefin tuna migrate so they can feed in waters rich in food, and also so that all the tunas can return at the same time to the breeding ground, which make it more likely for them to have a successful breeding. The humpback whale is one of those whales who do a long migration, and we are going to look at the migration here along the coast of South America. So here we see all of the migration patterns of the humpback whales, but in the book, they only, on figure 3.49, they only look at the migration from the southern Atlantic up in the Pacific Ocean. Many species of whales, they migrate to seasonal feeding grounds, and it's the same with the humpback whale. Humpback whales shows that they make massive annual migrations, and they do so because during spring they need to go down to Antarctic waters where the melting ice causes a rapid increase of their food, because as the water gets warmer and there's more sunlight, and the ice melts, it releases microalgae, which are food for krill. Krill is a small species of crustaceans, and those are favorite food for the whales. The krill population is high, which makes a rich feeding ground for the whales. During the summer, the whales have built up a lot of fat stores they need for the journey back to the winter breeding grounds, and they can travel up to 7,000 kilometers to go back to the winter breeding ground. We still don't understand all the mechanisms that animals use to navigate during migration, but we understand some of them. Some animals, migratory birds for example, they use the Earth's magnetic field to use that for navigation. Other animals, they use position of the sun, length of the day, position of the moon, and even position of the stars. So this is pretty classical navigation that a sea captain 200 or 300 years ago himself would understand. Also, there's olfactory receptors in many animals, so they kind of use as a sense of smell, so they can smell kind of the river where they came from. And last but not least, many of them also use kind of develop a mental map of the route, so they can look for landmarks, so they can navigate from the same way that we do. This just scratches the surface of navigation, and it's a super interesting field how animals can migrate like 7,000 kilometers and find right back to the beach where they came from. It's magnificent that they can do it.